Good morning, students. In last lecture, we discussed about electric current density and resistance, Ohm's law. Yes, Ohm's law, and dependence of Ohm's law on dimensions of conductor. Okay, and yes, we obtained one equation. See, next today it is vector form of Ohm's law. What is vector form of Ohm's law? See, we have one conductor having cross-sectional area A and length L. So you know what is its resistance? Resistance of conductor R is equal to rho L upon A, where rho is resistivity. Rho is resistivity. Clear about this? Okay, we have obtained this equation. R is equal to rho L upon A. Now, current I is flowing from this conductor, so potential difference between two ends of conductor, between two ends of conductor. What is potential difference between two ends of conductor? V is equal to, we have one equation, II. V is equal to I. I can write this equation as V is equal to I. What is R? Rho L upon A. Rho L upon A. Clear about this? Now, V is potential difference between two ends. Potential difference. Hello students. Yes, we do potential difference. Potential difference is created when there is some electric field. So if I say electric field in this conductor is A. Electric field in conductor, electric field in conductor is E. Then what is relation between potential difference V and electric field E? Yes, you know this. V is equal to EL. How V is equal to EL? Potential difference between two ends, electric field in this conductor, and L is length between length of conductor. So we can write V is equal to EL. Yes, you know this equation, chapter number 2. Remember, V is equal to ED. So yes, I can write V is equal to it is EL. Now this equation number 1, this equation number 2. If you compare these two equations, you will get EL is equal to I rho L upon A. Any doubt? Okay. L cut. So E is equal to, it is rho I upon A. Now you know what is I upon A. I upon A, current upon area, it is called current density. So E is equal to, it is rho J. E is equal to, it is rho J. E is equal to, it is rho J. If I want to write this in vector form, then yes, I can write E is electric field and J is current density, where rho is resistivity. It is similar. Clear about this? Yes. E is equal to rho J. E is equal to rho J. Now we know that reciprocal of resistance is called conductance. Reciprocal of resistivity is called conductivity. Remember, 1 upon rho, that is reciprocal of resistivity, is called conductivity sigma. So you have to remember this. 1 upon rho, reciprocal of resistivity is called conductivity sigma. What is unit of resistivity rho? You can make from this equation. See, if you make this rho as subject, then rho is equal to, it is RA upon L. Okay, what is unit of resistance? Ohm. What is unit of area? Meter square. What is unit of length? It is meter. So meter cut. Then what is unit of resistivity? It is ohm meter. What is unit of resistivity? It is ohm meter. Then what is unit of conductivity? What is unit of conductivity? It is ohm meter inverse. It is ohm meter inverse. Clear about this? So yes, what is conductivity? Reciprocal of resistivity is called conductivity. It is denoted by sigma. It is denoted by sigma. So if now I want to write this equation, I can write this equation as E is equal to rho. I can replace by 1 upon sigma. 1 upon sigma. Or you can write this equation as J is equal to sigma E. J is equal to sigma E. And yes, this equation is called vector form of Ohm's law. This equation is called vector form of Ohm's law. Clear about this? Simple theory. How to start? Conductor, its resistance, potential difference V is equal to IR, put value of R, then another equation of V is equal to EL. Compare this to equation, E is equal to rho I upon A, E is equal to rho J. Reciprocal of resistivity called conductivity, E is equal to J upon sigma, J is equal to sigma E. That is vector form of Ohm's law. And yes, you have to remember each and every equation to solve questions. Clear about this? Okay. Now see, next theory. What is next theory? Next theory is about drift velocity. Now what is meaning of drift? What is drift velocity? That we will see. Yes, you know configuration of conductors. Conductors are made up of positive ions fixed on lattice points, while electrons are free to move in random direction. Yes, you know configuration of electrons. Okay, see, it is one conductor. Okay, electric field is 0, means in absence of electric field. In absence of electric field, as we have discussed in earlier lecture, okay, in absence of electric field, each and every electron free to move, they will move in random direction. During the random motion, they will collide with positive ions, and their direction after each and every collision continuously changes. Electron is moving with some speed, collides, its direction changes, speed remains same. Okay, so each and every electrons, they are moving in random direction. Each and every electron, they are moving in random direction. During such random motion, suppose we consider only one electron, see, one electron starting from A, colliding, and it reached to point B. Suppose in some time interval. Clear about this? When electric field is 0, absence of electric field, electron moves from A to B. Hello, electric field is 0. So force acting on electron due to external electric field is also 0. Okay, in this case, force acting due to external field is 0. Now second case, see here, electric field is not 0. It means between two ends of conductor, one cell, battery is connected. Battery that provides EMF, electromotive force to give motion a charge. Okay. See, now when this conductor is connected with cell, battery, as this end is connected with negative terminal, potential at this end is negative. At this end is connected with positive terminal, potential at this end is positive. So at this end positive potential, at this end negative potential. Due to this, electric field is produced in conductor in this direction. Electric field is produced in conductor in this direction. Clear? Okay. And due to this electric field, negatively charged electrons experience some force. Negatively charged electron experience some force, and due to force they perform accelerated motion. Clear? So when electric field is not 0, acceleration of electron is A is equal to E upon m. You know this equation. It is force upon mass. And electrons are dragged. Yes, due to electric field, force is acting on electron. They are performing accelerated motion, but for very small time, because electron is performing motion. See, electron is performing motion due to force. Okay, it is moving, then it collides here. At the point of collision, its velocity becomes momentarily zero, and then it will move in another direction. Then it will collide, it will move in another direction. Clear about this? During this, its acceleration A is equal to, it is EE upon M. EE upon M. Clear? But this acceleration is for very small time. Between two collision. Between two collision. Okay. So, when electric field is non-zero, acceleration of electron A is equal to EE upon M. Due to this acceleration, electrons are dragged. And now, see in first case, due to external field, force acting is zero. But in this case, due to external force, some force is acting. Due to external field, some force is acting. Due to external field, some force is acting. And due to this force, electrons are dragged from A to B dash instead of A to B. Instead of A to B. Simple. Due to electric field, there is net displacement of electron B to B dash. B to B dash. Electrons are more displaced. Electrons are more displaced due to electric field. So, effective displacement of electron is BB dash due to presence of electric field. And the velocity of electron corresponding to this displacement is called drift velocity V. It is called drift velocity V. Velocity achieved by electron due to presence of electric field. Due to presence of electric field is called drift velocity. Is called drift velocity. Clear about this? Electric field zero, electric field not zero, moving from A to B, moving from A to B dash. Okay, not B to B dash, some more distance. So there is some net displacement and velocity related to it. It is called drift velocity. Okay. Okay. Relaxation time tau. What is relaxation time? See here in this last figure. See, electron performs numbers of collision during its journey. Okay. For example, from here, electron is moving. It is colliding. So, from this point to this point, it takes some time. For example, T1. Then, from this point to this point, T2. Again, colliding from this point. So, its direction changes. Another collision, it takes some time. Another collision takes some time. Another collision takes some time. Another collision takes some time. So see, here electron moves from point A to B dash after numbers of collision. Okay, and between two collision it takes some time. For example, T1, T2, T3, T4, T5, T6, etc. What is relaxation time tau? Relaxation time tau is average time between two successive collisions of electron. Okay, it is average time between two successive collision. It is called relaxation time. Okay, it is called relaxation time. How to relate this relaxation time tau with drift velocity Vt? Let due to acceleration A, drift velocity achieved in time tau is Vd is equal to A tau. Vd is equal to A tau, and therefore drift velocity Vd is equal to, what is value of A? Value of A is, it is EE upon M into tau. This equation you have to remember. Clear about this? Okay, so it is drift velocity and relaxation time tau. Okay, pause your video and write down from board. Okay students, next theory is you have to obtain relation between current density and drift velocity. So what is title? Title is you have to obtain relation between current density J and drift velocity V. Okay, so make title relation between drift velocity and current density. Okay, see, we have one conductor of cross sectional area A. This conductor is connected with battery, so obviously electric field is created in conductor. As shown in figure, a conductor having cross sectional area A, electric field E exists in this conductor, and also assuming that drift velocity of electron is V. Now suppose I am assuming electrons are moving from this cross sectional area. Electrons are moving due to drift velocity in this direction. See, for electron, drift velocity is in opposite direction of electric field. For electron, drift velocity is in opposite direction of electric field. Clear about this? Okay. So yes, I am assuming electrons are moving with drift velocity Vd from this cross-sectional area. Let in time t electrons reach to this portion. So in time delta t with drift velocity Vd, what is distance traveled by electron? What is distance traveled by electron? Consider one electron initially. We are taking one electron. This electron with drift velocity Vd is moving from this portion to this portion in time delta t. So in time delta t with speed Vd, what is distance traveled? Distance traveled is L. And how to write this L? See here. The distance traveled by electron in time delta t with speed Vd. You know one equation? Speed is equal to distance upon time. So distance is equal to speed into time. Yes or no? Yes. With speed v in time t, what is distance traveled? X is equal to vt. Here in time delta t with speed v, what is distance traveled? L is equal to vd delta t. So this distance L is equal to vd delta t. Clear about this? Now electron is moving from this cross-sectional area to this cross-sectional area in time delta t. So what is volume of this portion? Between this two cross-sectional area? Volume of portion of the conductor whose length is L. V is equal to, you know this equation, volume is equal to cross-sectional area into length. Volume is equal to cross-sectional area into length. So is equal to A. What is value of L? It is Vd delta t. Clear about this? Okay. Now the distance traveled by one electron. The volume of the portion of the conductor whose length is L. I have discussed about one electron. Now in conductor there are numbers of electrons. So I am assuming one quantity. Remember this thing. If numbers of electrons per unit volume, which is called number density, is n. What is n? Numbers of electron per unit volume. Means if volume is 1, numbers of electrons are n. Here what is volume? Volume is V. Then numbers of electrons in portion are, numbers of electrons in this portion are, it is NV. Clear about this? Simple. N numbers of electrons per unit volume. So in volume V numbers of electrons are NV. So is equal to, it is N. What is value of V? It is A Vd delta T. Numbers of electron. What is charge of one electron? E. Charge of two electron? 2e. Charge of 3 electron? 3e. 4 electron? 4e. Charge of NaVd delta E electrons? Yes. Charge crossing this time in A time delta T. Delta Q is equal to NaVd delta T into E. Clear about this? It is numbers of electrons. So here Yes, you have to multiply E, that is fundamental charge difference. Yes, here negative sign of electron is neglected. Okay, because we want to find only magnitude. So delta Q is equal to NA/VD delta TE. It is amount of charge crossing cross-sectional area in time delta T. So how to find current? Yes, you know equation of current. Current I is equal to delta Q upon delta T. Delta Q, put equation of delta Q, and A VD delta T. Here it is T divided by delta T. Delta T cut, delta T cut. So what remains? Here it is I is equal to N A VD E. Clear? Now if I take A this side, then it is I upon A is equal to N E V. Clear? I upon A, yes, you know it is J. So therefore J is equal to N E V. J is equal to N E V. It is equation. It is equation that represents relation between current density J and drift velocity Vd for electron. If I want to write one general equation, okay, then how to write this general equation? J is equal to NQVD. Q for any charge. Q for any charge. Clear about this? So J is equal to NQVD. J is equal to NQVD. Okay. Also, we know that J is equal to sigma E. Vector form of Ohm's law. J is equal to sigma E is equal to NQVD. Is equal to NQVD. Clear about this? Now J is equal to sigma E. Sigma E is equal to NQ. What is equation of VD if you remember? See, it is QE upon M into tau. It is QE upon M into tau. Yes or no? Yes, you know it. Okay, so this E cut, and sigma is equal to, see here, it is N. Yes, here it is N. Then it is Q into Q, it is Q square. Okay, then it is tau. Here it is tau divided by N. Clear about this? Okay. Another equation is equation of conductivity. What is equation of resistivity? Resistivity is reciprocal of conductivity. So resistivity, rho is equal to, it is M upon N Q square tau. It is M upon N Q square tau. Clear? What is the general term? See, rho resistivity, M mass of particle, N number density of charge, Q charge of particle, and tau relaxation time, that is average time between two successive collision. Clear about this? Now from this last equation we will classify metals and semiconductors. Okay, what is difference between conductors and semiconductors? And resistivity depends on which factor? Clear about this? What is title of this theory? Relation between current density J and drift velocity Vd. Clear? Pause your video and write down from board. Okay, topic is continue. See, rho is equal to M upon N Q square tau. What is M? Again, mass of particles moving. Okay, for example, electron. N, number density. Q, that is charge of particle, and tau, that is relaxation time. Okay, now here we will discuss about what is effect of temperature on resistivity and conductivity. Sigma is equal to, it is N Q square tau upon M. Okay, so we will discuss what is dependence of temperature. See, in case of metal, if we change temperature, see, in metal, mass of particle, number, density and charge. These three things does not depend on temperature. Does not depend on temperature. This relaxation time tau depends on temperature. How? See, if temperature increases, temperature increases means energy of electrons increases, their speed increases. Speed increases, so to move from one point to another point, it takes small time. So this relaxation time tau decreases. Relaxation time tau decreases. Clear about this? Again, as temperature increases, their energy increases means drift velocity increases. Their relaxation time tau decreases. What is relation between relaxation time tau and resistivity? Inversely proportional to. So if relaxation time tau decreases, its resistivity increases. So in short, you have to remember, as temperature increases, resistivity of metal increases and sigma, that is conductivity, decreases. Clear about this? Okay. Again, temperature increases, energy of electron increases, they are moving with more speed, relaxation time tau decreases, rho increases with help of this equation. Okay. Second, for semiconductors. Yes, for semiconductor we will study in detail in chapter number 14. But right now for this chapter, yes, in semiconductor, as temperature T increases, here number density means numbers of electrons and holes. Number density increases. Now what is the relation between number density and resistivity? Inverse. So if number density increases, resistivity rho decreases. Clear? So when n increases, resistivity decreases. So what to remember? In metals, with increase in temperature, resistivity increases. In semiconductor, with increase in temperature, resistivity decreases. Or I can say conductivity sigma increases. Clear? We will study about semiconductors in chapter number 14. Clear about this topic? Okay. So it is, yes, such questions are asking MCQ. Okay. What is dependence of temperature and what thing changes? Okay. Now next topic is mobility. What is meaning of mobile? Okay. Not this. Okay, yes, it is called mobile, but what is actual meaning of mobile? Mobile means things we can carry from one point to another point. It is cell phone, but we can carry the cell phone from one point to another point. That's why it is called mobile. Okay, vehicles, they are called automobiles. Because they they are moving from one point to another point. Here in this chapter we have to study about current. Current means flow of charge, means charges are moving. So any charges, they are moving, they form current. Proton, particle, it is moving, it is carrying charge. Electron, it is particle carrying charge, so it is moving. So when proton and electron flows, they form current. So yes, conductivity is due to mobile charge carriers. In conductors, mobile charge carriers are free electrons. While in electrolytes, mobile charge carriers are positive and negative ions. While in semiconductor, mobile charge carriers are electrons and holes. What is hole? Concept of hole we will study in chapter number 14. Okay, so mobility means mobile charge carriers for conductor, electrolytes and semiconductor. Now what is definition of mobility? See, we know one equation. J is equal to N Q V. Yes or no? J is equal to sigma E is equal to N Q V. Okay, now if I take this ratio VD upon E, then what is VD upon E? What is Vd upon E? It is sigma upon NQ. Is Vd upon E, that is drift velocity per unit electric field, is called mobility and is denoted by mu is equal to sigma NQ. Is equal to sigma NQ. What is mobility? How mobility is defined? See, drift velocity per unit electric field is called mobility of charge carrier. Clear? Okay, so you have to remember what is definition of mobility. Mu is equal to Vd upon E. Mu is equal to Vd upon E. Okay, now I can write this equation as C. Sigma is equal to mu and Q. Sigma is equal to mu and Q, where mu is mobility and number density and Q is charge. And Q is charge. Okay. Now, in case of conductors, see, it is equation of sigma. Sigma is equal to mu and Q. In case of conductors, charge carriers are electron. So in conductor, current is formed due to free electrons. So in conductor, how to write conductivity? Conductivity is due to electrons, means sigma E is equal to mu E and E. And what is charge of electron? It is E. Clear about this? Okay. In case of semiconductors, current is due to electrons and holes. Then here conductivity, total conductivity in semiconductor, sigma is equal to sigma E plus sigma H. What is equation of sigma E? Mu E N E plus, here it is mu H and E. Now you may ask one question, sir, why it is E? Hole is nothing but deficiency of electron. That we will study. Okay, next chapter. So here it is sigma, conductivity of conductors. Okay, for different material, for conductor it is conductivity, for semiconductor it is conductivity in case of mobility. Clear about this? Okay, students, pause your video and write down from what?